So this example does involve the quadratic formula, something you need to know. I might let you guys use it on a quiz or test. So let's go ahead and take a look at this example. We have 3x to the 7th plus 12x to the 6th minus 21x to the 5th. Absolutely.
That's a formula?
We're going to be using, we're going to be using two different methods for this. Factoring out a GCF and the quadratic formula. Remember from yesterday, we didn't do this yesterday, but I told you guys, whenever you're finding x-intercepts, the very first thing you should do is look to see if you can pull out a GCF. Okay, a GCF is like a term that goes into all three of those things. Okay? Well, notice that the smallest power is 5, right? So that means x to the 5th would be the largest, power that would go into all three of those, right? X to the 5th goes into the x to the 7th and x to the 6th. So that gets started with that. And then what number did you say? Yeah. And then the number would be 3, okay? 3 goes into all three of those numbers. There is no bigger number than that. Okay, 6 wouldn't work. 7 doesn't work. 3 is going to be the biggest. So the GCF is going to be 3x to the 5th. Okay, so always pull out a GCF when possible. So for this one, we're going to pull out a 3x to the 5th. Now, how does that work? Well, how many times does 3x to the 5th go into 3x to the 7th? You'd have to multiply by x squared to get 3x to the 7th. The two powers would add to give you the 7. And then you would see how many times does 3x to the 5th go into 12x to the 6th. Well, 3 goes into 12 4 times. And then x to the 5th times x would give you x to the 6th, so it's 4x. Good way to check this is if you remultiply this out, you'll get this expression up here, which is why the final number is minus 7. Because if you take negative 7 and multiply 3x to the 5th, you get minus 21x to the 5th. So always pull out a GCF first. Now, I think on the worksheet, most of the time I don't think you actually have to do that. You can go straight to quadratic formula. Okay? And quadratic formula always works when you end up with a trinomial like this, a quadratic trinomial. In other words, it has 3 terms. Actually, it works for all quadratics. So anytime you have an x squared and nothing bigger, you can always use the quadratic formula. So you don't have to write this down, but if you try to factor this, and we'll do that another day, okay? This is the X method. I think you guys were calling it something else. But the point is, it won't work, okay? So that's why a lot of students like to just do the quadratic formula, because it always works. That's why we're doing that today. But at least write down what A, B, and C are, okay? A is the coefficient of x squared. B is the coefficient of the x term. And C is your constant number, okay? We're going to be using all three of those when we use the quadratic formula. All right, next step, if you forgot from yesterday, to find a 0, you set the entire equation equal to 0 once you factor it all the way, okay? So we've already determined that this can be factored as much as possible, so we're setting y or f of x equal to 0. And remember we talked about that on the x-axis y is always 0, which is why all x-intercepts have a y value of 0. We have 0 equals 3x to the 5th times the factor. Let me ask you guys something. How many factors do we have here? How many factors are in this equation?
3, 4.
I'll give you a hint. This could technically be in parentheses. It's the number of parentheses. How many sets of parentheses are there? Yeah. So it's how many things are multiplied by it. It has nothing to do with how many terms are in the parentheses. It's how many sets there are, okay? So 2 factors. Next step is we're going to set each of those factors equal to 0. So I'm going to start with the first one. which is 3x to the fifth. Now, if you divide by 3 and you take the fifth root, you get x equals 0. So that's going to be our first x-intercept. Whenever you just have a factor and it's just an x term, 3x to the 7 or whatever, it's going to be 0. Okay? Because again, 3 times 0 to the fifth is just 3 times 0, which is just 0. All right? So that's the first factor. That's the easiest one. The next one, we're going to be using the quadratic formula. And if you want to write it down on your worksheet, whatever helps, feel free to do so. Yeah. All right, you don't have to write this down because you already wrote A, B, and C, right? But we're taking this factor and we're setting it equal to 0. And the only way to solve is the quadratic formula because we already tried to factor it, right? Actually, there is another way. It's called completing the square, but we're not going to go into that. Quadratic formula is easier. Okay, so go ahead and write this formula down. The formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And it's not too bad because if you have a, b, and c, then you're literally just plugging those numbers in and simplifying it. That's all you're doing. Whatever you get is going to tell you what your x-intercepts are. Okay, so we're going to plug in a, b, and c. Use parentheses when you plug them in. All right, so here's my b term. Notice I'm plugging it. I'm using parentheses when I plug it in. There's b again. B right there. You only plug in b twice. Plug in at the negative b and at the b squared. All right, here's my a term. You also plug in the a twice. Once on the top and once on the bottom. At the 4ac and at the 2a. And then for the c term, you only plug in once. But again, notice, always use parentheses when you plug it in. Once you plug it in, then you use the order of operations to simplify the expression. All right, so I can go ahead and do what's inside the radical. Okay, well, the negative 4 just stays negative 4, so that's not much. And then inside the radical, we have minus 4 times 1 times negative 7. We have two negatives, which make a positive 28. All right, and then the 4 squared is 16. So I'm just working it within the radical first. Okay, in other words, you apply the exponent and then you multiply before you add. Any questions on that? Oh, and you can multiply the bottom as well. You can do a lot of things in the first step. 2 times 1 is 2. All right, so now that you've done that, you're going to add 16 and 28, which is what? Good, thank you, 44.
Is that supposed to be y equals to 0 and no x equals 0?
No, that's a good question. With the quadratic formula, it is actually x equals. It's going to give you the x value of your x-intercept.
We're finding x twice. Or no, we just know y. Oh, okay.
Yeah, exactly. You know y0. Yeah, exactly. I know. I see the confusion there. All right, so let's talk about breaking down radicals. When you're breaking down a radical, you want to find a perfect square that goes into it. So with 44, you want to let's talk about perfect squares for a second. Let's do a different slide here so you guys don't get confused. 1 squared is 1, 2 squared is 4, 3 squared is 9, and we got 16, 25. So you want to check to see if any of those go into 44. You want to find the biggest one of those that go into 44. Well, definitely 36 doesn't work, 25 doesn't work, 16 not quite, 9 doesn't work. So the biggest perfect square that goes into 44 is 4. So you want to break it down as such. 44 is the same as 4 times 11. And then all you do from there is take the square root of 4, which is what? Whoops, let's not use that anymore. 2. Okay? So you're going to get this square root of 4 right here is just going to become 2. So once you break that radical down, you're then going to take every term on the top and divide by 2. I'm actually going to show that step here in the middle. So we're going to take that negative 4 on top and divide by 2. And then we're going to have the plus or minus, and we're going to take the 2 radical 11 and also divide by 2. Those 2's will cancel, and you'll end up with that on the right, and then negative 4 over 2 is negative 2, like that. Now when you use the quadratic formula, usually you're going to end up with 2 answers, and you're going to end up with 2 answers because of the plus or minus in the formula. Oh, you don't have to show it. If it makes sense to you. You talking about the middle step I showed? Yeah, you don't have to show it. But that's what you're doing in your head. Yes?
Would you accept one answer if we just leave the plus or minus?
Yeah, that's fine. Because it is basically 2 answers in one, right? But if you want to show it as 2 answers, it'd look like that. Negative 2 plus radical 11, and then negative 2 minus. So one of them has the plus and one of them has the minus. So this particular quadratic equation actually has 3, right? Because the first one we found was 0. And then the second one was negative 2 plus radical 11. The third one was negative 2 minus radical 11. Just for the sake of understanding, you guys don't have to write this down. But to try to figure out where it's going to fit on the graph, we can convert those numbers to decimals, right? So the first one's easy. We already said it was 0, 0. If we do this radical and work it out, it's about 1.3. And then the second radical, we worked that out, it's about negative 5.317. That's going to look like this on the graph. So you got an x-intercept there at 0. You got one at about 1.3, and the third one over here is at negative 5.317. So polynomial can certainly have, 3, 4, 5, 6 intercepts. Usually I think, though, for the sake of this lesson, it's going to be 2 or 3. So I'll be walking around helping you guys with quadratic formula if you need it. Let me just figure out which questions in the worksheet pertain to that.